Everybody. Thank you so much for joining us this morning or afternoon. And we are very excited to have Andrew Nelson with us today. Andrew is a farmer and a computer scientist and has been using FarmBeats in his fields, which you can see here on this slide, for the last 2.5 years. So we thought it would be a great opportunity to hear about what he's done and how he's using it in practice. So Andrew, turn it over to you.
All right. Well, thank you, Elizabeth. So I just wanted to give a quick overview of why I decided to, and pursued the FarmBeats team to use on my farm, and just give you a quick background. So about 8 years ago, I moved back from the Seattle area to my farm and was looking at ways to utilize technology to help our farm be better. I took a lot of processes that my dad and my grandpa before him did by hand, mostly record keeping, stuff like that, and made it digital. So I made a few apps, made some spreadsheets to really reduce time on kind of just administrative busy work. And after I got a decent amount of that, kind of taken care of, and so that way I didn't have to focus as much time on busy work, I was looking at other ways to utilize technology to help our farm in the future. So what I, looked around and read some talks from Ranveer or watched some that he gave, and actually just by happenstance, he was looking for a farmer to test out some stuff. This was about 2.5 years ago, so him and I got in contact, and I started using FarmBeats on my farm. And I really try to use absolutely everything that is within FarmBeats and kind of prove it out on my farm and show where it can be valuable, what are some of the biggest, quickest wins that you can make on your farm utilizing technology. And then some items I do, are just kind of more research oriented to be able to further things along down the road. So some of those changes are, I do a lot of drone mapping. I now have a spray drone, so I use that on some of our fields. I utilize sparse sensor networks to be able to better see what the climate's like throughout my whole farm, which is quite different throughout all of it. And then you kind of use the FarmBeats research preview a lot, and also the FarmBeats public preview. Use both of those sites to kind of tie it all together. Click to the next slide here. So I was thinking that what I go over in this talk is to go over the connectivity diagram that I have for our farm, how I have everything connected together. FarmBeats allows for so many different types of connections. I think that's really great to be able to go through them and see how somebody has their farm set up and how flexible it can be. Then I'll go into just some more practical things about station setup. When I got the first weather stations to put out on my farm, I realized, it was like, well, yeah, we can just put it on a post, but that wasn't really gonna achieve the result that I wanted, because I wanted it, in the field in a certain spot, and I didn't want to have to take a post in and out. So it's always nice to, think about some of those things that don't seem to be very important. They're not very techy, but yet they have a very big impact when you're using the tech. So I'd like to go through station setup for that. Look at a precision map for sensor placement. Go over some microclimate predictions. Go over Visage, which is a intelligent edge where I can, with one click, auto stitch, upload, and view drone flight information. And then just kind of a little bucket of additional insights that I've kind of thought of and ran across. And while we're going through the slides, if anyone has questions, we may touch on some of those before we get there, but I just wanted to make sure that we didn't lose them. And this way it's in a PDF where you have the slides yourself so you can go through them later if you want. And then after that, we can go through some questions. So starting off with the connectivity diagram. So I'm in my home office right now. This is where I do all of my edge processing. After I do drone flights, I'll bring in the SD cards here. I have a small, actually, Intel NUC computer, but it doesn't have to be Intel NUC. It can be any type of computer. I just happened to load mine up with a bunch of RAM, so that way it can do loss stitching. I load up my drone images. I have my computer here that I can open up my, different pages for looking at the different sensor stations. And it's the place with the best internet access. So best internet access doesn't mean that it's great. During the weekday, I'll usually get about 10 to 15 down and about 4 megabits up, which is okay for living in the middle of nowhere, but definitely leaves much to be desired. And then in the evenings, it'll usually slow down to anywhere from about 6 to 8 down at night. So, it's definitely something where I do have reliable internet out here, but it's still a big pain point for me trying to get reliable internet and fast internet. So the Intelligent Edge just sits on my desktop. I also have a LoRa sub-edge here. So some of my sensor stations connect up with LoRa, and some of them connect up with TV white space. The ones right next to my house are just on LoRa. It was easy to set up way to get the first stations running, and but the problem is it only works about as far as I can see out of my office. So from my home office, I have a connection to my shop. Right now, a little wireless connection. And on the top of my shop, I have a TV white space antenna. So it's just a little diagonal antenna and Yagi antenna, if you know what those are. I see there's a question. Hakeem? Or are you just clicking the hands up for fun?
He's experimenting with the buttons.
Can you hear me now?
Yeah.
Okay, yeah. I don't know, I have a Microsoft Surface Book. I'm looking to get a Surface Book 3. That's an advertisement for you. But in any case, you said the LoRa sub-edge only works as far as you could see. Is that because it's line of sight, and what type of distance do you get?
Yeah, it's line of sight. The furthest distance I've got is 3/4 of a mile. You supposedly can get a mile, but then you basically need to have your antenna outside and literally line of sight, not just line of sight through a window. So my reliable connections are from half a mile and closer through a window in my house. I've had one on a non-line of sight, but that was only at about 200 feet. So moving on, the TV white space connection is because I have non-line of sight to a shed on the top of a hill about 3 miles away. So I'm kind of down in this hole where my shop and house is, and then the shed is over 2 hills away from me, but it's on a hill, so I can have, higher antennas for connectivity. I use TV white space because it is non-line of sight, but it is a very strong connection to make from my shop to that shed. So there's about a 50 or 100-foot hill in between me and this shed, and it still connects up just fine. And there's also some trees in the way too. So that is really nice and really made it a lot easier for me to do this. Otherwise, I would have had to make multiple hops if I were using some, a Wi-Fi technology or something like that to get internet over to this other location. The shed has power, which is one of the other big draws for me to place something over there. I have land that's on higher hills, but there's no power. And the amount of, solar power that I would need to build and save, energy for to run everything would get pretty expensive. So at that shed, I have another LoRa sub-edge to have a weather station just right there at that shed. I also, when I'm doing drone flights over there, I will connect into, I just have a little Wi-Fi set up at that shed. I'll connect into the Wi-Fi and stream the drone images back to my home stitching computer. So that way I can fly the one field that's right there and start transferring those images back. And while I'm flying the other field on the other side of the road, I can start the stitching on the drone images. And it means one less field I have to stitch when I get home. It stitches pretty quick, anywhere from 3 to 10 minutes, depending on the field size. And some of these field sizes are, 300 plus acres. But it's still one less wait period that I have to go through.
Andrew, could I interrupt with a quick question?
Mm-hmm.
Sorry to interrupt like this, but for some reason hand raising isn't working, or at least I'm not getting feedback that it is.
No problem.
I'm trying to get a sense of the geographic layout of these different locations relative to the fields. So you talked about a home office, a shop, and a shed, and the shed is 3 miles from the shop.
Mm-hmm.
Where are the fields exactly, and where is the shop relative to them versus the shed?
So the shop is in a low area surrounded by hills. So I'm in the Palouse area of Washington State. So we have all these beautiful rolling hills that make it really hard for for wireless connectivity. And so the shop is down and there's hills kind of all around it. So it's blocked, you can only see half a mile to a mile away in any direction around the shop. Mm-hmm. And then there's some hills between the shop and that shed that's on one of the higher hills. Mm-hmm. And so if you were to go back to I'll just quickly go back, actually, if you go back to this slide, you see how there's all these rolling hills around. Imagine my shop is down here in this draw. Mm-hmm. And then this hill, well, it'd be a little further than that, but this hill over here where my neighbor's house is, that would be like where the shed is. So I have the TV white space set up pointed that direction, but there's a long hill in the middle, and it's able to get the signal over that hill and to that shed to get connectivity.
And is the shed the one that's closest to most of the fields, or are they both surrounded by?
So the shed, they're both close to a lot of the fields. The shed's main draw is that it's on a high enough hill where I can see line of sight to some fields that are 8 miles away. Mm-hmm. And when you're getting past 5 miles, line of sight with TV white space, the IoT TV white space, works much better when you have line of sight, especially at further distances.
Okay.
So that's why I wanted to put it up at that shed, so that way it could be able to see all the way to a lot more fields and cover a lot more area.
Mm-hmm. Got it. Thanks.
If I put this IoT TV whitespace tower at my shop, I'm only going to be able to access 10% of my fields. Now with it at my shed, which is on a hill that's about 150 feet taller, and then my tower itself is 25 feet. So that 175 feet is giving me access to about 80% of my ground versus that, 10% of my ground.
Okay. This is a pretty sophisticated setup, I should say. Way more than what we're going to have for a while. Yeah.
It's exceptional. If you don't mind me interrupting, Andrew, I don't know which of are you working with one of the Microsoft contractors, the subcontractors on the TV white space, or did you do this all yourself, or how did that work?
So I work on the team. Benefit of being a software engineer.
Got it.
So that's kind of the nice thing is I'm able to test these things out. I work on the team, testing them, and I'm able to get kind of the real world value out of it pretty quickly, since I know what I need as a farmer. So that's kind of how it usually works. And then I work with the engineering team a lot. If I have any questions or if we run into anything, sometimes we'll tweak what we're working on based off of, oh, I'm trying to implement this, but here's a roadblock that I'm having.
Andrew, this is Elizabeth. Did you install the TV Whitespace towers yourself?
Yes.
How hard was that?
The actual tower, which I was hoping to get a picture yesterday, but I wasn't able to. The actual tower itself is just a tower like you would have at your house to get over-the-air TV channels. So it's not that hard. It is putting it up 25 feet is difficult. Me and somebody else who works on our farm, a high schooler, it took all of our strength to get it up to that 25-foot height. So I'm not going to say that was super easy, but it's any tower that you're using for like receiving television station channels works great for a TV whitespace tower as well. And the other thing is we were trying out this tower that cost $100. That was a lot cheaper. Actually, it was $100 ship, so it was like $80 if you happen to go and get it at Walmart. So there are nicer towers that are much easier to set up, but the price goes up with the better ease of setup.
Got it.
So all the things I try in this setup that I have on our farm, I try to make sure that I'm very price conscious. Just like since I am a farmer, I know how tight margins are, and a lot of these things you can't be spending a lot of money on, especially if you want a bunch of sensor stations around your farm. You don't want to be spending, $1,000 on every sensor station, because that price adds up really fast. So that I always try to look at the costs of everything involved to make sure that we aren't using something that isn't practical when using it in the real world.
So Andrew, this is Vikram again.
Mm-hmm.
So I don't know if you've thought of any setups more focused on research goals rather than this kind of production farm setting. One of the things we're trying to decide is what set of sensors would be the most useful on a smaller field, but for experimentation.
Mm-hmm.
I don't know if you'll talk about that later, but if you do, it'll be valuable to hear your thoughts on that.
Yeah, I think we can cover that later.
Sure.
I'd like to go through some sensor setup
Sounds good.
slides, and but let's definitely touch on that at
Sure.
the end. So last thing is, the sensor station, 4 miles away, non-line of sight is what I've been able to connect reliably at. I did a test this last fall, and I was able to get 16 miles away line of sight with a reliable connection. That was with my tower placed on a taller hill, but that connection did work quite well. So, the higher you can get the tower, the better, I guess, is the moral of the story there. So the sensor station setup, I say I have 2 versions. I actually have 3. The first one just didn't work. My sensor station blew over the first night. It was a little windy, but it shouldn't have blown over. The materials did work well, but just didn't work well in reality. So my first version, I just used pressure treated wood connected to a stand made, kind of out of scrap iron that I had around, rebar, solid inch tubing, on square tubing on the bottom, and then it's a 3/4 inch pipe that goes up the top. Readily available at any hardware store too. I have access to a welder, so I welded it up. It does work quite well. It's pretty stable. As you can see in the picture, I do have blocks on the base, just make sure it stays stable when we get really big wind gusts. I like that it is a little taller, but the problem with that is when doing any field operation, it has to be removed. And being that it's metal and then you have these heavy concrete blocks, when you're moving it for field operations, even if this were in a test plot and you're having to do field operations there, spraying the test plot or anything in it, the problem with that would be that we have to move it, and it's very heavy. So I have to bring out my side-by-side, load it up, move it, have to be careful when loading it up to not hurt the solar panel, and this is just very cumbersome. The height does allow for better radio communications, so when I place this one further, it works better with LoRa. But there's other ways to get around that. You can have an external antenna. You can get little what they call pigtails to extend the antenna outside of the sensor box, and that ends up working pretty well. I do really like having these on multiple parts of my field, or if I were to have or in different fields where I'm running trials of stuff. So as a farmer, I am always wanting to try the new thing, but I need to prove it out on my own fields. Just because a acre trial says that some chemical or some variety works well, that doesn't mean that it's going to work on my 320 acre field. So I like to make sure that I have a sensor station at every spot where I'm testing this out, so that way I also know what the weather was like. So if the field did exceptionally well, but it got 2 more inches of rain, which is very possible in my area. Right now there's a field that has 3 more inches of rain than any other of my fields, even though it's within 10 miles. So I need to know that data to know, well, was it just that it got more rain, or is it that, this variety is actually that much better, or, the different practice I did in the field. So my favorite setup is this. It doesn't look quite as pretty, but it's extremely functional, very cheap. and very easy to make, which I think fits really well with university research. So the really nice part about it is you can go to any home building place and get the Schedule 80 PVC. Mine's rated for outdoor, and it's still pretty cheap. Everything for my sensor or for, the stands costs $20. That includes all the elbows. That doesn't include the sand, but sand's very cheap. The nice thing about the 2-inch conduit on the base is I cap off the base and I fill it with sand. So I have a nicely weighted stand. This is a little shorter one because I like to keep it closer to crop. But I have made taller ones and they're just as sturdy. So this is really kind of my favorite design. This station was on the top of the hill this last winter when we got 75-mile-an-hour winds during a winter windstorm, and it did not budge. So, it's very hardy, and I mean, for that price, I haven't seen a easier or better way to do it. The other nice thing about it is it's actually quite easy to just pick up and move, or just pick up and set, because it has a weighted base. You can set it in the back of a pickup, set it in the back of a side-by-side, move it out when you need to do field operations and move it back, and it's quite easy. And if you need to, take your station back to do repairs or add or remove sensors to it, it's not a big deal. You can screw right into the PVC. This is what most of my sensor stations are everywhere, because it has worked so well. I do have one that I mounted on a fence post that I drove in to the ground, and I have to say, I am repurposing it for my orchard right now because it was terrible. You have to, move that fence when you're doing stuff. This is very easy to place right on the same spot. Sometimes I'll just put a flag where it was, so that way, I make sure that the station stays at the exact same spot. It's worked out really well. And then with the TV white space sensor, the only difference really is I just mount another metal plate to the top of it and put on the CB antenna which is what I use for my antenna for TV white space IoT. I really like the 3-foot CB antennas with the magnet base. They're really cheap. You can go to any trucking store or any ag retailer, pick them up for $5 to $10, and the 3-foot one seems to get better results. I don't have hard data on it because I wasn't testing side by side on the same day, but the 3-foot one is what I was able to achieve those 12+ mile connections, stable connections on, and just seemed to work really well. I see Stacy's question, how many sensor bases do I have over the whole farm? Right now I have 10, and it is, I'll probably keep it around that amount, 1 per 1,000 acres. Mostly because you have to, periodically go and check on them, clean them, set up everything. But I will have some fields where I do have multiple. So I'll have 10 locations, and then one field I'll have 3. So I'm able to do some different things in that field where I'm able to do the AI prediction on soil moisture, for example. I need 3 sensor stations in the field to do that. And that's why they work up really well. And I need to move the station setup because For example, when I'm planting the field, I want to plant the whole field. I want the station to be in the crop. So I'll move it out of the way, plant the field, and then put it back. So that way my soil moisture sensor is in the same place as growing crop. It seems to give me better results and results more like what the reality is. And if I'm spraying, you know, I usually, depending on what I'm spraying, I usually like to move them out of the way so I'm not spraying chemical over them as well. And I've tried doing machine data through TV Whitespace. I had my combine connected up to it last year. Unfortunately, I was using the bigger TV Whitespace I have connected on my shop, the same one that I connect to that shed. And I was connecting to that. The problem is my shop's too low, so I'd have to put in another TV Whitespace antenna up on that higher hill to be able to get wider coverage. And right now, the IoT TV Whitespace is a very low bandwidth, low power specification for just IoT devices. So really just for sensor stations sending low amounts of data. It can't send enough data to be able to, you know, pull the data readout from my, you know, CAN bus or something like that. CAN bus is what I'm looking for. So the IoT TV Whitespace, they both use TV Whitespace frequencies. The IoT uses this little card here, if anyone can see my screen. So this is the IoT TV Whitespace card. So it's a very low power. I can run it on four AA batteries for over a week. You can pick your frequency based off of which plug you plug into, frequency range. And this streams, I think it's 128 kilobits a second at the max. It is used for sensor stations and IoT devices, getting connectivity on that very low power usage. The other one that I have is a large Yagi antenna that's about 4 feet long. It has a high-powered radio on it to use the more commercial TV Whitespace connection, which is used for, you know, serving broadband even to rural internet users. I would like to make a permanent station setup that doesn't move around, but the hardest part is, you know, I'm a minimum till person, so I still till. If it were in a corner of a field, that works. The hard part is usually, you know, they're a little taller, and one of my neighbors actually put a Davis one on one of his corner posts. You know, it's sticking up a little bit so it could get the wind. The first year he had it there, he hit it with a spray boom and broke the $500 weather station. So that's why it's quite nice to be able to move it. So just a quick overview, the kind of cool AI things that we're able to do using Sentinel data. This is a screenshot of the sensor placement map on my fields. So using the past, specified months of data, you can specify how long. So I specified growing season from June until the end of July, when I had a lot of growing going on. It will look at the field using the NDWI images and determine spots on the field where you should place sensors to then be able to infer what the soil moisture is throughout the field. So that's what I did on this field. It's 100 acres. I placed 3 soil sensors throughout that field based off of the sensor placement map. And I was able to see what the soil moisture is doing throughout the year. And, some of the things I'm using for that is being able to figure out, okay, for next year, what am I going to plan for my crops? Because it looks like I have a lot more available deep, soil moisture in certain areas. And for this year, depending on what the weather has done, can I put a little more fertilizer on? I saw a sub-edge. How many do I use in total? Ideally, I'd use just like 1 or 2. 1 to run TV Whitespace, 1 to run LoRa in my home office. Right now, I run 4 of them. So 1 at my house, 1 at that shed, 1 at a neighbor, at somebody who borders one of my fields, where I'm gonna put a TV Whitespace sensor station, but haven't got it out there yet. So I was able to use their internet. And 1 at another further field away to do the same thing. Thankfully, I know a lot of the people who live around our field, so I was able to just ask them and plug it in. It uses so little bandwidth that most everyone was fine with me plugging it in. So I already kind of touched on this, the microclimate variability, where we currently this spring have a field with multiple inches more of rain than our other ones. And so if you see the little white lines on my map, that is where TV Whitespace can connect from my one location with IoT for my sensor stations. So I can get a wide spread among our fields and be able to see where weather has moved through. I'm also using that in addition to some of my neighbors are starting to use some other weather stations on their fields that have publicly available information. The only problem is some of them, I'm skeptical at how well they're keeping up the field. So that's why I'm not, or keeping up the weather station. So I don't quite know how reliable their data is. So that's kind of why I still need to rely on my own data because I'm not sure how their maintenance is on their weather stations or if there's any at all. This better coverage does help a lot. It helps a lot with field operations when we're really busy. Instead of saying, oh, should I move to this field? I can quickly pull it up on my phone and see what the soil moisture is like and say, oh yeah, the soil moisture is low enough. It's 30%. I'll be able to do, the planting that I was expecting to do there today. It saves me about, 4 hours from driving around to every field. And that 4 hours, especially in springtime, can make the difference, in a month of getting planting done, because sometimes if you don't get that 4 hours done, you're delayed a week or 2 based off of rains, and then you have to, spray again later. So or do your other field operation later. And that's where it's really helpful. Some of the WSU trials here are utilizing some of my weather station information, so that way they can kind of have the same thing, because they have trials spread all throughout and they need to know which one they should go to first, which one can they work on first, and instead of just going in the same order, they're utilizing some of that same sort of information to be able to be more efficient at what they're doing. The really cool thing, at least I think really cool, that we were able to do with these sparse sensor stations is to run microclimate forecasting on them. Able to use an AI model to predict temperatures. It works really well for lows and high temperatures. Last year and this year, it saved me from spraying when it was going to get to below freezing. So looking at the weather forecasts, I have 5 weather forecasts on my phone. Looking at all of them, there has been multiple times where they showed that it was supposed to stay above freezing. And my microclimate prediction said that it was supposed to freeze, and it did actually freeze in all the lower areas. And that's where I was going to spray. And if I would have sprayed and it froze, that would have impacted my yield anywhere from 10 to 50%, depending on how heavy of a freeze it is that night. So this is something that is very useful to me, especially during spring operations, making sure that I am protecting my crop, yet doing it when I can, but not, just more information helping me make better decisions. So I'll quickly touch on the Intelligent Edge, which for me is a very handy device. It sits on, my computer in my office. My bandwidth is limited, most in rural areas is. And I'm able to take my small SD card, so just the SD card out of my drone. I'm able to plug it into my computer, run one command, and since I have my fields already mapped out in FarmBeats, it's able to detect which field the flights were from, stitch them, and then slowly upload them without taking all my bandwidth. So the stitch images will stay on my computer. I can look at them immediately, and then eventually they will get to the cloud, and I'm able to look and access them anywhere then. Or I can run additional AI on them in the cloud. It is getting some AI on my computer, being able to do stitching algorithms and such. It is very helpful for me to be able to do that and not kill my internet connection, because there's been multiple times when I'm stitching and uploading and also, trying to log into my chemical supplier or some other website. And the old way doing it of transferring everything up to the cloud would have just trashed my connection. I would have had no connection. For example, yesterday I did 500 acres worth of drone flights. I wouldn't have been able to use my internet at all yesterday if I didn't have this. So I was able to do it. I was able to see my stitched images, and then I saw this morning when I got up, everything was up to the cloud, even the full resolution images. So I wanted to quickly touch on a feedback loop example, and then I'm going to try to go through these pretty quick so I have some time for questions. But I think this is really important to see, the full loop of the technology impacting what I'm doing in the field. So for this field, we had some grassy weeds. It might be a little hard to see here. I tried to magnify it, but there's little grassy weeds in the middle of this picture. I didn't have it over the whole field, just spots. And so I wanted to effectively spot spray it. So I was able to take a drone image. Last year, what I did was I drew it out on my GPS information for my sprayer, for my ground sprayer, and drove around the field and sprayed it. The field that had the most grassy weeds was only 10% of the field. Most are less than 2% of the field. So usually I only have a few acres of every field that I'm having to spray. So this year what I ended up doing was I ended up buying a drone sprayer. So since I'm only doing a few acres in every field, this field had it down this little draw and then up a little bit to the left. I was able to plug in the GPS coordinates of where the weeds were on my drone sprayer, have my drone sprayer spray it while my ground sprayer was doing other operations. And I was able to get the chemical on it more quickly. And also with the drone sprayer, atomizes it better. So it was able to get better coverage on those grassy weeds, which in our area, Italian rye, is very resistant and very tough to kill. And this was actually able to take care of it. So worked out really well this year. Just reading the quick comments here. Yeah, so I do look at them quickly with the raw view, but try to go from there. I don't have NVWI or NDI sensors on my drone, but I try to get them. A lot of the grasses and weeds I can see from the field with raw image, trying to find more effective ways to be able to automatically parse those. I hope that was answering your question. My additional insights, feel free to look at them in the PDF, but I'd rather have some more time for questions if people have questions.
Andrew, do you want to go back to your insight slide?
Sure.
Okay, great.
So, you know, the big thing is you really do need to think about field operations when doing any technology on using any technology on the farm. And I think that a lot of people forget about that because you still have to farm. Routine check of stations is also very important because you don't want to have junk data coming in. The TV white space tower is nice to have it easily accessible. I had an issue where a rodent climbed up the tower and ate my antenna. The way I had it built the first time, or ate the antenna cable, it was very difficult to access. So that made it a big issue. Those heavy duty truck CB antennas are great for TV white space. Very resilient and very cheap, which is why I like them. And the weighted weather stations, I can't stress that enough, help so much. And it is, once again, really nice to be able to move it if you need to. And if you have trials in a different spot, that way the next year you can move your station setup from one field to another.
Andrew, as questions come in on chat, could you read them just in case somebody's on the phone? Okay, awesome. Thank you.
So I have one question here. What are some thoughts from your neighbors about the technology? Have they thought about FarmBeats adoption themselves, especially since they're losing $500 weather stations and FarmBeats is supposed to be low cost? Yeah, I've had some talk with me about it. Some are a little scared off by the amount of setup involved. And to be honest, FarmBeats is more meant for researchers and companies to build on top of, not for the end farmer consumer. It's not that a farmer couldn't do it, it's just that it's not really built that way. It's more built for a chemical company or another value add company to add insights on top of. But a lot have talked to me about it. They really like the idea of cheaper weather stations, and pretty much all of us agree that having a $1,000 weather station or $2,000 weather station in your field just does not make sense. Because, to have too many of them, to have enough of them to help, and the amount of accuracy that you get for that additional price doesn't currently make a big enough difference in the data that you're able to get, versus the no data that you have now. So I see Dennis's question. As we want to make the dollar case for IoT and ag, can you point to top one or few key decisions and related actions that you use to justify your tech? So I'm pretty pragmatic. I justify my tech by making sure that it can pay for itself. So for example, when I bought my drone last year, I thought of a way where I could reduce my grassy herbicide spray by 90%. That paid for, I could have bought 10 drones. But I look at those first quick gains to get technology in the door, and then it's more incremental gains off of that. So made that really great ROI last year, which is literally why we had a profit on my farm. The amount that I saved was almost equal to my profit. And this year, that's why I ended up getting the drone sprayer. It's not saving me as much, but it's still saving me and should be a return on investment within a year. For the sensor stations, those ones are harder to figure out the return on investment, but they are very valuable when you look at your neighbors and how much more effective you're able to be. So I'm able to keep spraying, keep doing field operations, usually a couple days every season when they are sitting, because they didn't, drive to every single field and check it. And I'm able to check it on my phone and say, oh, we can just move to this field and keep going. Elizabeth had a question. What are you most looking forward to being able to do in 2 to 3 years from now using tech on my farm? More of these feedback loops, definitely. So I hope I have another few drone sprayers actually within that time frame, so I'm able to do a feedback loop on that and be much more precise at every chemical I'm putting on my field. I'm also hoping that I'll be able to have some better AI insights on my fields and start breaking down the chunks of my field that I am managing from, field wide. I'm now down to sub-field, but I'd like to be down to acre within 2 to 3 years and sub-acre after that. I think that the kind of micromanagement of your fields is very important. Soil and everything is so different throughout fields that it's not all just the same. And you're welcome, Dennis.
It looks like, I know we just have like a minute left. It looks like a couple last questions coming in.
Yeah. So what versions of the sensor boxes am I using? I'm using version 2. Version 3 is a little easier to connect to TV white space to than version 2. So that's the main difference. The bandwidth with TV white space for the commercial version that I'm running over to the shed, that's a high bandwidth. I do about 12 to 16 megabits per second with that. With the IoT, it's in the 128 kilobits. Is it fair to say that with less field stations and tech in general, then you have less accuracy? So it comes down to decision making, understanding the trade-offs, cost, performance, reliability. It's a balance of how many stations do I want for better accuracy versus how much money do I want to invest in placing sensor stations around. It's definitely kind of you need to find the balance point. Any specific sensors I would like to add? We have some CO2 sensors that I'm collecting data on, but I'd like to figure out ways to utilize that data better. I really would like to have a real-time NPK probe. So that way I could see nitrogen, phosphorus, potassium in my soil and know how the crop is using it. What bottleneck is today in analyzing images down to the per acre levels? Vikram, we can definitely take it offline. The Visage has really helped, to take away a lot of bottlenecks. There's still some in the pipeline for running AI on it that we're looking to solve to make it much easier to analyze images, but then also make it so I can use it in our platform. Thank you, Chris.
So,
I really appreciate that.
I think this was fantastic.
Thanks,
Andrew,
everyone.
thank you so much. I think we have to stop. We're at time, but we'll put a copy of this meeting and the slides and maybe some of these additional questions up on the team site, and we'll send out an email just to make sure everyone can access the team site going forward. So thank you, Andrew. Really appreciate a great presentation.
Thank you, everyone. I really appreciate it. Feel free to send emails if you have questions.
All right. Thanks, everyone, for joining us. We'll see you again next time.